The agenda of today's session is going to be quite extensive. We are going to have a number of participants who are going to be presenting a lot of different aspects from the metallurgical industry topics, but also related to waste management. We're going to delve into a number of different considerations in that regard. We have the pleasure of having first at 10, quite in a second, Costanzo Pietrosanti from Danieli Automation, who's going to start with a more holistic view of the digitalization of the metallurgical industry, and followed by presentations from our ALCHIMIA coordinator, Carmen. Henry from the GRINNER project is also going to make an intervention of waste management. Later on, moving on to a presentation by Daniel Gomez, who's another project coordinator from the Self-X Artificial Intelligence project, and also delving into steel and aluminium use cases. Later, we're going to have a presentation from Jonas Pettersson from PURESCRAP, another research project as well, focusing on scrap handling. And finally, AIDEAS project, a presentation by Grigoris Tionis, and this one more about multi-source data acquisition and sharing in industrial equipment lifecycle using machine passport. So without any further ado, I'm going to give the floor to our esteemed speakers, and starting with Costanzo. So if you would like to share your screen, you're very welcome.
I see that there was an inversion between my presentation and the one of Carmen, yes, because my presentation was regarding the economic perspectives of growth. But it doesn't matter. If you want, you can start just now.
Yes, please.
Okay, that's okay?
Yeah.
Okay, fine. Just a moment. Okay. Everything is visible. We have checked before. My name is Costanzo Pietrosanti. I'm a senior consultant for Danieli Automation, and I work in the field of the digitalization and industry 4.0, 5.0 of the steel making industry. I was a former director of the CSM division of rolling mill and automation and control in my former career. And now, actually, I'm retired and I'm working for Danieli. So I will introduce you just a few slides, giving you some hints, not more than that, just to focus in that the focus of the presentation is how to measure the digitalization evolution inside the plant. Because I think that there is a parallel, an example of applicable to the steel industry is that the pathway to the smart factory or the industry 5.0 model is something that seems to be the pathway of a mountaineer that has to use a compass for understanding where he is going. So one of the key points of this transition between the current status, I mean the automation and control of the 90s, to the actual one is something that has to be measured because, as we will see, it asks for a very huge investment. So in Danieli, we have developed a methodology and the relevant tools to assess the maturity of the progressive achievement of maturity of a plant as considered as a complex systems and the readiness. In combination with that, there are also other aspects such as the measurement of the impact that the digitalization can have on the system. So lastly, I should give you some economic numbers of what is the growth of the digitalization and digital technologies to consider separately in a worldwide perspective of the industrial context. So you can see just a couple of definitions. We use the maturity that is in practice the degree of compliance to the smart factory paradigm or to the smart factory or Industry 5.0 reference model. The maturity is something that different from the readiness, that is the ability of measuring business processes. And it is an aspect that is fundamentally based on the measurement of the capabilities that increases, hopefully, I should say, during the evolution of the digitalization. That means the deployment of new technologies and new advances in this field. So we developed a methodology that we called the QS scan, that with the relevant tools. There are 3 separate software tools that was developed just to support the global assessment. This is founded on the method of the round tables between experts, with the addition of some neutral technicians that help or criticize the selection that has to be made. So the basic of the methodology is founded on the preparation of the so-called digitalization maturity matrix. And for doing that, we need the methodology for measuring what we want. It means that we have developed a very simple matrix, but very complete, and that make the assessment of separate areas or separated parts of the plants or an entire production system. This is very general and applicable outside of the steel field. So the digitalization maturity matrix is something that has some cells. It looks like an Excel file, but it is not. Such cells are calculated and filled with numbers that are called the basic digital index, that are calculated by attributing scores. The scores are attributed based on experience or modeling or the impact of the digital technologies on each aspect that are considered. So the digitalization matrix, maturity matrix, is accompanied by the digitalization readiness matrix. The matrix is almost the same, similar, but of course the meaning is different. So the basic digital index fully considered is simply the sum of the scores normalized by the sum of the maximum achievable values. I will show the digitalization matrix in a few seconds. So it means that the meetings in which the round tables are made, are held, is founded on consensus. There is a discussion, there is an evaluation, and the model of the plans is designed according to the need of what we want to measure. It means that the matrix is something that replicates the design of the production systems in terms of area, assets, and systems. Oh, this is the aspect of the digital matrix. And as you can see, there are some classes of digital technologies that are considered. So in this case, connectivity and data sharing, data processing, human in the loop, modeling, and autonomous and robotic systems. The This is an old version. It was developed 2 years ago and that applied in many plants of our customers to help them to decide how to invest, in which direction, and which kind of technologies can be considered for the digitalization transition. So as you can see, the matrix consider the total per category, and in the black line there is something that went wrong. It is each cell that is behind that is below the digital type of digital technologies. For example, local area network or web-based application, Wi-Fi, whatever you want in this sense, is filled with a value that is decided by the consensus meeting. So the sum for each class of basic digital links is obtained and put in the total per category row. Then there are the thresholds or other concepts that are very long to be explained, so I jump directly to the conditions. What is interesting is to make a first evaluation to determine what is the as-is condition of the plant in this moment. So in this example, I am considering something that is the situation of a rolling mill area of a plant, of an American plant of our customers that was updated 2 years ago. Updates was finished last year in 2020, beginning 2023. And the new condition was measured and compared with the expectation, because in the general aspect, I must say that we have a first matrix that is the as-is, a prediction to provide the awareness about the expected improvement and the quantification in numerical terms, and then the update to the real condition after the enhancement of the digital landscape. The trick is to make the comparison between the two and verify this point during the progressive growth of the digitalization. So in this case, another example in which I use another kind of graphical aspect and robustness. In this case, there are the situation, the preceding situation to this slide is the calculation of the digitalization matrix and the decision of the areas on investment. In these cases, we had the fortune to have the two melt shop in the plant. It is another plant, not the American one. And the decision was to invest in digital, putting everywhere digital pulpits, virtualization of local control station, application based on AI, increase the connectivity and data processing according to the reference model of the Industry 5.0, that one of the main aspect is the full integration of data exchange in practice, the energy management, and the equipment for life tracking of a product in terms of quality and other issues that are selected case by case. So in the radar graph, you can see on the right side, you see the digital maturity, the gap analysis of the digital maturity. In blue, there is the as-is status at the beginning of the revamping, and in orange, the situation in the to be. To be means that as is now, today. And as you can see, the evaluation allow to determine, if you look to the blue area, you can see some eventual weak points that are, for example, no autonomous systems have been considered up to the date of the beginning of the revamping. Connectivity was still good in that condition, so it was just an intelligent maintenance, and eventually the deployment of AI-based application and particular big data applications. Data processing was instead increased and considered a weak point. Human in the loop was critical in the beginning. And the decision to go to deploy new technologies was centered on the deployment of some robots, in particular in all the melting areas, in the two melting areas, and in the human in the loop. Something in data processing, because it was the beginning of the progression towards the intelligent factory based on AI application, and in that stage, based initially on the deployment of machine learning applications. We will see something about the AI in the closure in the end of the presentation. So I think that this is quite clear, and if you can see data, the score scale stands between 0 and 10, but it is possible, decided by, under the decision of the experts. It is possible to consider also the second number after the comma. And in this case, what considers not only one value, the central one, but also there are other decimals that are, for example, if you look to data processing 5.6.6, and you can see the advantage obtained with the deployment of new technology. So this methodology allow to respond to the first question that normally customer ask us as plant builders when we approach them. What are the direction I have to embrace for enhancing my adherence to the industry 5 or 4, as you wish, .0 reference model. Mainly this is the situation is the reason why we start with the analysis of the existing situation and the effect we expect in terms of capability, digital readiness, and in terms of the adherence to the model, to the industry 4.0, with the maturity concept. Once we have the availability of such information, we have to decide which kind of digital technologies we have to provide. Because, as you know, just now the question is focused on the AI. Because AI together is perceived as the biggest disruption emerging in the digital transition. This is, in my opinion, this is just the concurrence of many factors, because there is the holistic effect that sometimes is declared but not fully explained. For example, can AI take place without proper infrastructures? This is a very big question. That means that that explains some aspects that we will see just in a few seconds. Considering that it is so really pervasive as expected, and the answer can be helped by the looking where the money is going. We performed, based on the literature data from the most popular observatory of investment in expenditures on digital technologies, considering 3 KPIs: the global market size of expenditures, in particular, how many billions of dollars are spent worldwide in the industrial context. It means all of kind of industry are monitored with a sampling a statistical application. And then to measure what is, to have an idea of the global market size of expenditure GMS today, and projected to the 2030. So this is the final answer. I will show you is the forecast according to the most popular observatories to the 2030. The second KPI is compound annual growth rate, that is in practice an expression more advanced of the return of investment, but it is also a description of the expectations, because it is defined as the rate of return that would be required for an investment to grow from its beginning. It is a data that can be interpreted also as the expectation that investors put on the investment in terms of increase of capabilities of their manufacturing system. The third aspect is something that as KPI was defined during the analysis. The first, that is a business analysis, and is the compound economic factor of digitalization. That is a medium value, that a mediation between the GMS, I mean the global market size for a given technology, and then the expectation, that's the CAGR in a unique KPI. So at the basis of this analysis, there is a selection of 15 significant technologies that has been considered and monitored in terms of the 3 KPIs. If you can see, we have IoT, cloud computing, big data and business analytics, AI and ML. ML means XL because reinforcement learning, deep learning, what you want. Digital twin, edge computing, industrial automation, industrial logistics, virtual reality and augmented reality, industrial business intelligence, cybersecurity, industrial robotics, modeling and simulation in industry, data centers, and platform economy. In our opinion, and in the opinion of the most important researchers and economic researchers in this field, this 15 technology gives an idea about where the money are going now and will go in the future. Then, after having analyzed the resulting score for each KPI, we provide the ranking of according to the 3 KPIs. It is very interesting to look first to the global market size of expenditures. So you can see here that the expectation regarding the AI and ML put it in the 5th position of investment with $333 billion. That have to be compared with the IoT technology, that is an infrastructure, that is $1,700 billion worldwide in 2030. And you can see, if you look to the first 4 positions, sorry, you see that with the exception of big data in business analytics, that is higher than AI and ML in terms of expenditures, the other are typically infrastructure. It has a clear message. There are a lot of people that deployed AI applications without having the right infrastructure to support them. And this is the enabling factor. It is one of the main points to be considered to transform the analysis into an holistic analysis to understand what is the combination of the value, not the value given by the sum of the simple impact of each technology. And it means that after this point, in fact, we have clusterized the analysis and obtaining very good results. Unfortunately, I do not the work is under the way, but it is the right approach. But also, I must consider such a number very interesting, because if you look at the expectations, the return on the investment, IoT is still in the first position, with cloud computing in the second, and AI and ML grow up to the fourth position in 2030. And regarding the combination of the two, we have the emergence of the digital twin, because a digital twin is something that is in seventh place, considering the expenditures, and with a very good performance in terms of return on investment. And so it put it in the first position for considering the combination of the two factors.
Constanzo, if I may intervene, can you please wrap up, because we need to also give the time to other speakers?
Yes, immediately. So I will show what is the final business analysis at a glance. That it means that you have to consider in the analysis two factors. That is very important to decide how to invest. What are the enabling technologies, but what are also the other factors, other technologies that enable the enablers towards the Industry 5.0 or the smart factory to achieve the final result we have in mind in terms of the intelligent factory. And this kind of analysis that combine the two aspects I shown in this intervention, it is, in our opinion, a very good way to help our customer to design their updating plant, look into the future, considering the AI. It is, if you sum the infrastructure typical of the AI and the AI, you obtain the result that the AI is in first position. And it means that you have to consider much higher cost than the simple approach to the AI, as anyone can expect. So thank you. I'll wait for your question later. And thank you once again.
Thank you very much for your presentation. If there are any questions in the audience, please do not hesitate to write them in the chat so that they can be taken later on during the panel discussion. Thank you, and I will now give the floor to Carmen to make a presentation on behalf of the ALCHIMIA project. Carmen, the floor is yours.
Thank you very much. I think you can see my screen. Okay.
Yes, we can.
Okay, perfect. Okay, then first of all, thank you, Costanzo, for this interesting presentation about the digital maturity matrix, a very useful tool. Also, Anna, thank you very much for the organization of this webinar. And good morning, my name is Carmen Perea. I work in Evident and Atos company, and currently I am the ALCHIMIA project coordinator. The purpose of today's presentation is to introduce you the ALCHIMIA project. Let me summarize briefly the structure of this presentation. Firstly, we will see the main data of the project. Secondly, we will learn about the consortium composition. Then we'll take a look at the challenge that the consortium want to overcome through the project. After this, we will review the ALCHIMIA mission, we will formulate the main outcomes and goals of the project, and to finalize, summarizing the main ALCHIMIA vision. But first, some relevant data about ALCHIMIA. The project was submitted to the topic Data and Decentralized Artificial Intelligence for a competitive and green European metallurgy industry, AI, data, and robotics for the Green Deal. The project
Apologies,
type,
Carmen, but I think there's a problem. I think GRINNER is sharing their screen.
yes, I don't know what, yes, let me, now?
Yes, it's back. Yeah.
I don't know why. Okay, it's correct, no?
All good.
Yes, the project type is an innovation action with a budget of more than 3 million euros and a European Commission requested contribution of more than 2.5 million euros. The project started in September 2022 and it will finalize on August 2025, a duration of 3 years. If you want to know more about us, you can visit our wealth of social media where you can find more information. Yes, the partners typology is divided into the following categories: end user, academic and research institution, and industrial companies. Then allow me to introduce you the consortium. The consortium is composed by, in the center, we can see the project end user, CELSA Group, with their factories in Poland, France, and Spain, and the Fonderia di Torboli in Italy. The project is supported by the sources of knowledge of research institutes and universities. These are the German Research Centre, BFI, the University of Cardiff in UK, and Sant'Anna in Pisa, Italy. Also, thanks to the Foundation Mandat International, we have the leader of dissemination and exploitation of the project. Furthermore, we have the partner ESUS as our technological provider, and last but not least, also supporting the technological side, we have Atos as the project coordinator. But what are the challenges of our user? The ALCHIMIA project tried to overcome the challenge in an electric arc furnace-based steel producer, CELSA, and in the manufacture of these brakes for the automotive industry, Fonderia di Torboli. Currently, those production processes in the EAF plants can be improved in various ways. For example, the classification and characterization of scrap is relatively crude, the steel recipes are based on experience, and the safety can be improved. And more knowledge about the EAFs can be acquired, preventing more exact control of melting process. ALCHIMIA then aims to optimize aspects of these processes. On the other hand, in the automotive plant, ALCHIMIA is designed to overcome an inherent problem related to the production of cast iron car parts. Some important quality checks can only be performed after a significant period of time passes, due to the need for product to have cooled sufficiently. Subsequently, the inspection of the product is conducted at a large state, with limited room for improvement. Then we can enunciate the mission of the ALCHIMIA. Our mission is to provide a comprehensive and effective platform for the metalworking industry in the European Union to support the transition of high quality, competitive, efficient, and environmentally friendly production processes, ensuring high quality products in the steel industry. Our outcomes, the outcomes of the project are a decentralized artificial intelligence and data solution in order to support the European Green Transition Strategy, demonstrate the ALCHIMIA potential for finding the optimal mix in the steel making processes, evaluate how ALCHIMIA is contributing to improve the environment through the reduction of CO2 emission, increase the circularity ratio, or reducing the slag formation. Also, foster and ensure the correct collaboration between workers and the AI solutions. Enhance the worker skills through artificial intelligence, but putting the user in the center. Establish also links and synergies with the EU for AI platform, Gaia-X, and the European Common Data Spaces, and also ensure the communication and exploitation of the ALCHIMIA results. Then, what are the ALCHIMIA goals? Well, between others, we want to support the green transition in the big European Union metallurgical industry, reduce the energy consumption, implement waste management in the steel making processes, achieve green production processes, manage the emission, enabling artificial intelligence application in an energy and resource intensive industry context, and advances in the EU and artificial intelligence strategy. Summarizing the key aspects of the project to finalize, the main goal is to build a platform based on federated learning and continuous learning to support the European metallurgy industry in order to take advantage of the different technologies. Technologies from artificial intelligence such as federated learning, continuous learning, explainable AI, and founding in the AI for EU platform. And in mind, we should have the optimization framework tools proposed by the project: scrap characterization, scrap inventory, and process models. Not forgetting the targets of environmental impact by LCA and the product quality as results as optimal share, mix, and optimal process control. With the following KPIs in mind, in TELSA and in the foundry: reduction of electrical energy input, saving oxygen consumption, increase of metallic yield, less consumption on the oxidation materials, reduction of the energy consumption of the waste material, the CO2 emission, and reduce the scrap material. Also, in a transversal way, the solution put in the center the human, using human-centric design, taking into account trustworthy AI, compliance with the ethical guidelines, and with the focus on the training of the workers to ensure a complete understanding and adoption of the platform. And that is all from our side. You can see here our social media, and I will give the floor to the following presenter. Thank you very much for your attention.
Thank you very much, Carmen, for this comprehensive presentation of the ALCHIMIA project. Now, without any further ado, we'll give the floor to Henry from the GRINNER project to also take the floor and make a presentation about improving waste management through AI.
Hello, everyone. I hope you're well. I wondered which screen you can see. Can you see my presentation screen or my main
We can
screen?
see your presentation screen. It's good.
It's good?
Yeah. All
right. So firstly, I just want to thank you for the opportunity to speak on this event. I'm sorry about the initial sharing. So today we're going to talk about GRINNER and why GRINNER, what GRINNER will do, and about the project. And it's we never get tired of the opportunity to share about this exciting project. Is my screen changing?
Yes.
Sorry, I seem to be having a problem on my side. So as it stands, there is no available solution to eradicate fires caused by so-called zombie batteries. So I begin with that because the essence, in fact, when we were putting the proposal together, it came to us as, one of, the impact as you dig deeper in terms of the problems in fires in e-waste that that are currently happening, which is, effectively why GRINNER. So what you have is batteries within the waistline, effectively igniting, and mainly lithium ion and nickel metal hydride, as shown on my screen. Now, the impact of such fires is that millions of euros of damage and serious injury, or even worse, death occurring in some of these plants. So what you've got there in front of you is demonstrating the extent of the problem. So a survey of 109 e-waste processors revealed that 36% reported a severe battery-related incidents between 2016 and 2019. And as you all know, lithium ion is growing more and more in terms of its usage and in components. In fact, one of the things that we encourage is, opportunity for anyone who hasn't been to one of such plants to visit, to just appreciate, and more and more things are now starting to have some of these batteries. So the problem that you're seeing here that we are highlighting isn't actually getting less, it's getting worse. And therefore, the need or the much need for a solution such as GRINNER. So again, the extent of the problem. So according to a survey, the cost of fires range between 190,000 euros, 1.3 million per incident. And by the way, this is a conservative figure because if you follow on some of the follow-on costs, shutdown, or even the potential loss of life, which of course you can put a figure to. So cost and consequences for treatment plants related to repair, replacement of equipment, temporary interruption, loss of waste burned during the thermal event, and then maintenance and replacement of extinguishing, the extinction means, and then any other related associated costs, like I mentioned earlier. Now, because of time, I have a video here that we usually share. And it's actually 15 minutes long, so I won't share it. But what we'll do is there's a link there that we've put, and for anyone who would like to just delve a little bit, just to see, from national bodies in terms of some of the impact, emphasizing what I've just mentioned. So to the next point in my presentation here to you is what will GRINNER do now that we've talked about the problems? Well, GRINNER aims to commercialize an autonomous AI-enabled robotic sorting system capable of detecting and removing this e-waste, right, containing the batteries from the current waste streams before now they enter into the machine. So you think about, for example, in the recycling plants, being able to catch this early, so that you're mitigating these problems and the fires that may result thereof. So the system will comprise of an X-ray detector and then a machine learning enabled software. So with the consortium, we've got some of the key elements that are being developed. Now these are top level, but just to give you a picture of how it will work. And then we have the objectives. So these are GRINNER's objectives. So build an X-ray data set of e-waste. Develop an AI software module for detecting batteries in e-waste. So this is the detection part. And then develop the prototype system and install it in an e-waste facility to conduct live trials. So one of the questions we get asked, are we going to trial this? Yes, we are. It's going to be trialed at the end of the project, of course, at prototype level as per the requirements of the project. And then finally, to explore the potential for exploiting GRINNER as an economically viable standalone product within e-waste plans. The expected environmental impact, again, here just to mention but a few, purely because of time. Top level is really preventing the toxic fluoride gas emissions that these fires would cause. And then the second one is reducing waste from materials destroyed by the fire, the follow-on fires and that will be banned. And then minimize contamination of water, runoff water using the fires to extinguish some of these. Again, very, very top level And then carrying on in other expected impacts is the economic, which I mentioned in terms of saving the cost of some of these damages of water, some of the figures that I presented earlier. And then the health and safety side of things. GRINNER will prevent and minimize the occurrence of battery fires and injuries linked to them. And then the fourth is societal impact, which is replacing humans working in dangerous conditions, which will result in less injuries. Again, catching this right from the beginning. Moving on to the next part on my presentation today is about the project. So now we've talked about why GRINNER and the objectives of GRINNER. So how about the project? Well, we are a 3-year funded project that began in August 20. That began last year, and it concludes in 2025. And we've got our consortium is made up of 7 organizations, and these are linked where we are coordinators. So I'm the coordinator of the project, and then we have the We Forum, TWI Hellas, Varex Imaging, Erion, s-X, and GRINNER being the end user of the project. So an image there of the happy team taken within at the kickoff. So once again, I just want to keep it very, very brief today. And just to give you top level, and because of time, I didn't want to take too much to extend beyond the time. But this summarizes the GRINNER project, what we are seeking to address, and how we're going to go about it. Thank you very much for your time.
Thank you very much for your presentation. I think it has already created some questions in the chat, so please have a look whenever you have a while. And also there were some questions for Carmen as well. So just passing the information, we can of course discuss this more in depth during the panel discussion. So
Excellent,
the next person on the agenda is Daniel Gomez Martin from Cardiff, who is going to be presenting the s-X Artificial Intelligence project. So I'm giving you the floor. Very welcome.
Hello, Anna. Thank you. Can you hear me perfectly?
Yes.
Yes. Okay. Thank you. I'm Daniel Gomez from Cardiff Technology Center, located in Spain, and I'm the current project coordinator of this s-X-AIPI project, which stands for s-X Artificial Intelligence for European Process Industry Digital Transformation. Sorry. No. This project is a Horizon Europe project that research, develops, tests, and experiments on an innovative toolset of custom and trustworthy s-X artificial intelligence technology for the process industries. These applications will not only minimize the human involvement in the loop, but will also exhibit self-improvement capabilities. Here you can see an overview of the project itself with a diagram that shows everything regarding the project, which is the development of that trustworthy s-X applications whose goal is to have an agile and sustainable process industry, always taking into account the different human in the loop, and also the whole value chain of the production process. And in this project, we have up to 4 industrial use cases. This project AI toolset technologies aims to offer more simplified interfaces that will not require a highly skilled workforce, will even have longer useful life, and will require less specialized maintenance, as I'm going to explain later on. Both the process industries and the workforce will be equipped with operational agility thanks to this toolset, performance optimization, and the use of cutting-edge AI-based tools. So what is the main innovation of the project? It's to provide to the usual AI data pipeline an innovative concept which is based on the so-called autonomic computing capabilities. which encompass self-abilities and the concept of the autonomic manager. With this, all the AI applications continually are updated with self-improving abilities by integrating the data with reduced human intervention. And at the core of this architecture is the called autonomic manager, also supporting the human in the loop roles. s-X-AI represents the fusion of the usual AI as the intelligent processing system and the autonomic manager, which was proposed by IBM in the environment of the IT field, but this time using the methodology called MAPK. MAPK is a methodology where the model encompasses a continuous cycle of monitoring, analyzing, planning, and execution flow based on the knowledge, I mean the data coming from the plan, of the system under control. As I said, there are 4 industrial use cases where this trustworthy toolset will be implemented. And if we focus on the steel use case owned by Sidenor in Spain, it focuses on optimizing the use of scrap to produce high-quality steel products, avoiding downstream surface quality problems and reducing process energy intensity. The improved control of varying steel scrap properties allows tighter supervision of scrap suppliers, support for enhanced uses of low-cost scrap types, improved process endpoint control, and an homogeneous production by shared knowledge. Therefore, this project is proposed for improving controlling the plant by using machine learning for calculating the scrap chemical composition, which is normally affected by disturbing elements like copper, sulfur, phosphorus, considered as residual elements which downgrade the steel quality and with high degree of uncertainty. The scrap mix that minimizes the cost and meets the customer requirements in terms of liquid chemistry and assure the best performance of the process for achieving the required steel temperature and chemical composition. The steel making process that is envisioned within the project still involves the operator taking decisions about machine set points, loading material, and chemistry control. However, contrary to the current situation, the developed support system will provide the different operators with insights about the scrap properties and furnace temperature and chemistry. This envisioned s-X solution will monitor the input and output data space to detect unexpected events or drifting of the tool's accuracies and propose corrective actions to regain and maintain the robustness of the system. Overall, the goal is to ensure resilience and accuracy on the temperature and the chemistry of the steel at the end point of the furnace treatment. Regarding the different human roles interacting with these s-X-AI solutions, the goal is to develop for the steel use case to facilitate the interaction of the operators, the different engineers, and even the data scientists with the different modeling tools via a single interface with the autonomic manager. The different roles of the human interacting with the solutions are as follows. The enhanced scrap supervision model will improve the available information on scrap properties, which is key information from scrapyard operators. The accuracy of the model is then envisaged to be high. Therefore, the feedback of the operators in the loop on the safety conditions to be included into the code will be relevant. Also, the knowledge about the prediction of the status of the chemistry and the temperature at the ending of the furnace step will serve as a guideline for the furnace operators. The feedback on the reliability of the prediction and the operation will serve to improve the machine learning calculation. Also, the autonomic manager will serve even to the data scientists to study the model independence. Thus, in this way, the autonomic manager will serve information about s-X detection and diagnosis of anomalies during the process and give a suggestion of self-repair to the data scientists. The role of the operators will be mainly to use the visual information as decision-making support, while engineers or data scientists will have even additional configuration possibilities. As an example, for determining the optimal charge material mix in terms of product quality and cost, a decision support system has been developed by our colleagues, BFI. For each steel grade to be produced, the developed tool determines the optimal charge mix, consisting of different scrap types and alternative ion sources. It considers the purchase cost of the materials, but also the cost for electrical and chemical energy sources to melt down the materials, and even their availability, either on the plant's internal scrapyard or on the market. For example, the figure shows the result of the calculation for an example of steel quality. If we focus a little bit on the next metallurgical use case, we have the aluminum use case, which also focuses on optimizing recycling processes from scrap. They also manufacture aluminum from scrap, reducing the melting power and time, optimizing metal yield, and improving liquid aluminum quality, leading to a decreased rate of downstream quality rejections. They are currently, with the help of another of our colleagues, Ayman, developing an intelligent decision support system, always within the architecture envisioned within the project, to, as I have said, optimize the production line of aluminum manufacturing. Due to time constraints, we cannot delve very much into this use case. Just as a recap, we are 14 partners from six countries involving large industry companies, research institutions, technical SMEs, and even a standardization body. If you would like to have more information regarding our project, you can contact us through the usual social media channels and even on the website. And that's all. Thank you. That has been a very, very brief introduction to the project regarding metallurgical use cases.
Thank you so much, Daniel. Very brief, but very comprehensive and insightful, I'm sure, for everyone over here. The next presentation is going to be by Jonas Pettersson regarding the PURESCRAP project and the use of sensors for better scrap handling.
Yep, thank you. So, hello, I'm Jonas Pettersson from Sverige, who is the coordinator of this project. Yes, you see we have the partners Sverige, K1 Metals, s-X-AIPI, Redwave, Danieli Automation, Santa Anna, LTU, Spectral Industries, TU Dortmund, voestalpine, Stena Recycling, and ESTEP. Okay. And PURESCRAP stands for Purity Involvement Improvement of Scrap Metal. And see, and it's a Horizon-funded project in the topic raw material preparation for clean steel production, and it started last year and it will end in June 2026. So, and here you see the spread of the partners centralized in Europe from north to south, and it involves 12 different partners in 6 different countries. Research organizations, universities, and also quite many manufacturing companies involved. And as you see, it's quite heavy on the technical side. On the technical partners, it works on the sensor technology and process control and data analysis, all for scrap analysis. And it also involves the scrap recycler. And end users of the scrap, so the steel producers. And also highly involved in the project is the social aspects of making sure the workers and users of the technology will understand and accept the technologies. And we have K1 Met quite heavily involved also in the dissemination and communication aspects, exploitation, and also involved in the metallurgical aspects of evaluating the results. So maybe you're curious what we will do now. So the objectives of the PureScrap project is broadly to enable an increased use of post-consumer scrap in the steel industry. Well, why? Well, it's of course important to improve the scrap usage, as you all know. And what limits the scrap usage is occurrence of different tramp elements in the scrap, such as copper, tin, nickel, molybdenum, that cannot easily be purified from the melt, and therefore the presence of those in the scrap will set limits to how much the scrap can be used. But if we can treat the scrap, there is still a possibility to use more scrap in Europe. So see here in the figures that we use, or as of 2022, we used roughly 80 million tons scrap in the steel production, and 58% of those were the scrap constituted 58% of the crude steel produced in Europe. But still we export scrap outside of Europe, and so there is availability of scrap within Europe that can be used if we have it, if we can control it, analyze it, and treat it better. So how do we do that in the PureScrap project? We do that by applying sensors in different parts in the scrap processing. So in the ferro scrap processing plant, we have mainly two different processing lines or processes. One for the heavy scrap, the large scrap pieces, which is typically not very much mixed or entangled. So and we have this shredder operation for more complex scrap, such as cars, for example, that needs to be dismantled so that foreign objects can be removed from the scrap. And those foreign objects can be, non-metallic parts, which can be filtered and away and also removed by fans or cyclones. And then eventually there is a magnet that picks out the magnetic part, so separates the non-magnetic from the magnetic fraction. And the magnetic fraction is what will then be sold to the steel industry. And we want to apply sensors both for the heavy scrap processing and the shredded scrap processing. And we focus on sensors for analysis and not so much on new technologies to remove scrap, because of the high flows of the scrap. So there's roughly 100 tons per hour. So it would require huge efforts and huge costs and investments to be able to remove any objects. So we want instead to use the sensors to better understand and control the already existing processes in the plant, such as how the scrap is selected originally and sent to the different processing lines, and also how the shredding and the following operations work. Yes. So we start from the scrap, put the sensors, and then we get the characterized output. And this also has another added benefit. Apart from that, we can manipulate how the operation works so that we can have slightly different outputs. We will also get much better understanding of what the scrap mix contains. And we will not just pile all scrap in one big pile. We will instead make smaller batches. And then each batch is well controlled and or well analyzed, I should say. And the aim is that each batch should contain so rather than having a huge mix with the average content and a large spread, we aim to have smaller batches with known content, such as so that the entire batch can be used as it is in the scrap charging. So, for example, in this mix of shredded scrap, there may be upper limit of 0.25% copper. But if we can separate it in smaller batches, each batch has a more well-defined copper content, and then they can be used because they can be planned and combined in a better way. And we focus not only on copper, focus also on tin and nickel and molybdenum, and in principle other elements as well. So where are we in the project? Let me do like this. So we have been working for about a year now. We have worked on the sensor parts to understand the processes at the recycling facility and set up the sensors in the right way. So they will now be started to be set up now during the spring, and sometime after the summer we will start to produce batches of characterized scrap material. So let's see here. And some more details of how what sensor combinations we use. So we use a combination of many different sensors, such as XRF, vision, LiDAR for 3D measurements, and LIBS for chemical analysis. And they all have their pros and cons. I mean, some cover the whole belt area of a scrap belt here. Some cover only a small point, but give a detailed chemical analysis. So we need to combine all of these to get a complete understanding of the chemistry, of the mass, and recognize foreign objects, get the shape of the scrap as well. So all of this information can be sent along with the scrap so that the charge can be planned optimally at the steelwork. And we will also investigate if we can use the different sensors to continuously train each other, so that, for example, the camera measurements can learn to identify chemistry directly, for example. Yes, okay. Coming to the end now, just to summarize, we look at both the heavy scrap and the shredded scrap, and we do that with slightly different sensor combinations. It's the same basic techniques, but in different setups because of the different scrap types. And we're in the beginning of the project, or initial phase of the project, so I cannot share results today, but hopefully we can share results soon in the future. So stay tuned for updates on the PureScrap website or on our LinkedIn channel or in future webinars like these. So with that, I would like to say thank you for your attention from all of the PureScrap project partners. And yeah, again, I'm Jonas Petersson from Sweden. So, thank you.
Thank you very much for your presentation. And now we're really much entering the final presentation of today's webinar before we move on to the questions and answers and the panel discussion. So the final presentation is from Grigoris Tsianis from the AIDEAS project, and it's about multi-source data acquisition and sharing in industrial equipment lifecycle using machine passports. So Grigoris, you have the floor.
Yeah. Thank you very much for the opportunity to participate to ALCHIMIA webinar. First of all, I will share my screen. Can you see my screen?
Yes.
Okay, thank you very much. I'm Grigoris Tsianis from CERT, research assistant, and I will present the AIDEAS project, AI-driven industrial equipment product life cycle boosting agility, sustainability, and resilience, in which we are the coordinators of this European Horizon project. First of all, we develop a functionality, a technology known as machine passport, in which is responsible for storing, sharing, manufacturing data through the product life phases of a machine, and more specific, the design phase, manufacturing phase, use phase, and repair, use, recycle phase of the industrial equipment. So at first, the whole meaning of machine passport is the data management, the data that we'll take and how we'll take them. And this data concerns design data, manufacturing data, use data, and repair, use, recycle data concerning a specific machine. So at first, we have two types of sources of data. The dynamic data, which comes from certain source or from databases, and static data, which comes from, let's say, files, Excel files, CSV, and etc. This knowledge is stored in a local database of this technology, machine passport. More specific, we are using MongoDB to store this information, and the communication is by using APIs, HTTP protocols more specific, and also we have solution for specific use cases, how to, let's say, predictive maintenance of a machine, to see a failure in a machine, to see when we have to repair a specific component of the machine, etc. So we have this solution, which is AI models, in which we give us information concerning specific use cases, as I said previous. So the machine passport takes knowledge from data coming from this phase, and also takes knowledge from machine learning models, and try to understand the situation of the machines and provide this information to the user to help him in the decision-making process. Also, we have implement XI algorithms, explainable AI algorithms, in which we'll use in the machine learning outcomes to, let's say, understand and provide more insights why we have, let's say, this situation for this specific use case. Let's now dive more specific in the use case we have. First of all, we have the design data, in which we'll create the data exchange protocol, standard, interfaces, how we'll manipulate this data, how we'll import this data to this smart platform, and we'll try with this data to, let's say, use them for the optimal construction of the industrial machinery. Concerning the manufacturing data, we also have to, let's say, create communication protocols, also the data management of the data, update, delete, and give specific information that the user needs. And this data of the manufacturing data applies to supplier, manufacturer, and customer data, more or less. Concerning the use data, also is data management concerning use data, and more specific, this data will give us information concerning optimal calibration parameters, how this, with which parameters, let's say, the machine will have a stable functionality, and all this data coming to machine pass will be able, let's say, to provide it to the user concerning the specific this specific life cycle of the machine, more specific the use phase. The final one, the final stage that we have in the machine passport, repair user cycle data, in which we will try to take this data and understand when we have to repair the machine, we have to reuse a specific component of the machine, we have to recycle the machine or the specific component of the machine. So to take advantage, the best advantage of manipulating the machine, the life cycle of the machine in the end. The general functionalities of this technology is utilities to acquire and store multi-source manufacturing data that are obtained throughout the product life phases. More specific, the use phase, the repair use cycle phase, and etc. Pre-processing methods of the acquired data to clean them, also see the missing values, ensure compatibility, durability, consistency, the data that will take. Also methods to provide this data using APIs and HTTP protocols, more or less. Definition of the protocols and the format of the messages that we have, let's say, have a unified structure for all the data that will come, or knowledge. Development of interface for smart, trustful data storage, sharing and exchange between different ideas suites, and also provision of the knowledge produced for the machine learning models and the explainable AIs that will give us more insight about the outcome of the machine learning models, the result. Why, let's say, from a machine learning model we have this output. It's information concerning interoperability and understand the user why we have this outcome and why to trust them. The architecture is more or less we have the machine passport front end in which the user is able to give command or ask what he wants to see, in which, let's say, he wants to see some data concerning manufacturing, he will do this request in the front end. This request will go to backend, and then based on this specific request, it will go to the database and let's say retrieve the specific information. Also, we have another component harmonizer will check this message, the structure of a message, to see if they have the correct format and it's let's say a valid message to proceed. Have as a validation component. And also have, if the user, let's say, in the front end wants to see the outcome of a specific solution, let's say, predictive maintenance of a machine, will go to this via the UI, will ask this information. Then this information will go directly to the solutions. The solution will take this input and provide the output in the machine passport backend, and then will visualize in the front end. Also have some other functionalities in which we are trying to connect with different databases, APIs, and files to the machine passport technology, so to be able to visualize this data, and more or less this concern NoSQL database, SQL database, Excel files data, and APIs. Technologies. The technologies that we are using for the machine passport is manipulation of static and dynamic data, as we said in the first slide of the presentation, supporting different types of data such as JSON, XML, CSV, and etc. Implementation technologies of communication architecture such as message buses and APIs, uses of different databases such as SQL, NoSQL, and we want to also include graph databases such as GraphDB, GraphQL, etc. Creation of APIs with the HTTP protocols for the communication between other components, because the solutions will be established as a components. They will not run in the Machine Passport backend. So have to establish communication, and also will create a security mechanisms for authorization, authentication of the user, what access limits will have, and etc. So try to minimize, let's say, the threats of concerning this data. Thank you very much for your attention. That's all from my side. We can find AIDEAS project in the browser, in the site that we have, in LinkedIn, in Facebook, in Twitter. And for more information concerning the program, please see this social media that we have. Thank you very much for your attention. That's all from my side.
Thank you very much, Grigoris, for your final presentation. That means that we conclude now the first part of the webinar, and we can move on to the next one, which is really this questions and answers panel discussion session. So of course, if you have new questions, please don't hesitate to drop them in the comments. And in the meantime, we're going to go for the questions that have already been asked. We have half an hour for these. So I encourage all the speakers to come back with their cameras on if possible. Thank you. So one of the first questions that has been asked was one actually from Costanzo to Carmen, so regarding the ALCHIMIA project, which was about considering the issue of standardization of data sets for assessing of the environmental footprint.
Yes. Yes, thank you for the question. We have here our expert, Petri Canisto from BFI, and he's going to answer this question.
Oh, yes. Thank you very much for the question. So if we will, it was about standardization, LCA. It is currently being discussed what the standardization outcomes will be from this project. So we are currently in the hot stage regarding standardization, so selecting what to actually contribute. So there are no concrete decisions about this particular factor yet. I hope soon. There was also the second question about standardizing LCA data sets, but do we have anybody who would actually know more about this method?
Yes,
in the webinar?
Yes, I think that Antonella is answering the chat also. I think she can.
Yes, I answered in the chat following the input of Costanzo Pietrosanto. I am not a really expert of the LCA methodology. Our colleagues are not in the webinar today, but I tried to answer, and thank you for the question. I think yes, this method is very useful to do a footprint evaluation, due to the fact that this method is able to consider various impact categories, for example, CO2, land use, water consumption, air pollution, and so on. And it is able to consider the entire life cycle of the product. In the case of ALCHIMIA project, the boundary of the system that we will consider is from the scrap consumption to the end of the ladle furnace. Furthermore, the idea of the ALCHIMIA project is to include the main LCA scores in the optimization problem in order to obtain a sort of online LCA. Such scores will be evaluated starting from a baseline, of course. Thank you so much. If you have further questions, please let me know.
Yes, I see that Constanzo has his hand up.
Yes, I have just a question regarding. I have two questions, but perhaps it is better to leave the space to other colleagues. And just you mentioned the fact of the online LCA. For doing what? Because you are aware that it opens a big door. What
Yeah.
about the sampling? What about the use for doing what? Counter reactions or whatever you have in mind?
Okay, because we have to find the best scrap mix for the objective of ALCHIMIA project, and we will of course consider economic factor, but and energy consumption and so on. But we have also to include the environmental impact. So our idea is to try to include also the results of the LCA in the optimization problem in order to obtain also the environmental impact of each scrap mix. I don't know if my answer is clear.
Yes, it is quite clear. I have just a point, but I think that it is considered in the ALCHIMIA project. That stands on the fact that to have an online LCA evaluation is of course an advantage. However, the problem is how to use it and how to provide this value. Because considering the assumptions necessary to evaluate prescribed by the current standards, I would say, to assess the LCA, the value is not, in terms of your reliability, it is a relative measure and relative and relative number, not an absolute one.
Yeah, it is an estimation.
Yes, it is interesting as well, but an estimation.
Yeah.
And the consequence on this point is that you need more data to make your prescription in terms of optimization reliable, as it would be necessary. So, but anyway, it is a good target. I share it. Your answer is okay for me. Thank you.
Thank you so much.
So we have another question here regarding the GRINNER project, which is about what will happen with the e-waste taken from the belt.
Yes, Henry here. Thank you for the question. Well, currently there's ways of sorting the e-waste. The problem and what we're trying to address is that when that e-waste gets joined up and in terms of not identified and removed from the recycling plant. So data that has been identified will be removed and put aside and then recycled appropriately. Because now you know exactly what you're dealing with, and there's already facilities and people dealing with that. And in fact, many of the recycling plants themselves have got areas of dealing and recycling it appropriately.
I hope that clarifies. Still another question for GRINNER, which was about whether you consider pressure vessels like I'm not quite sure how to say this. Laughing gas bottles.
Yes.
And flares and fire rockets.
Yeah, thank you for that. No, currently no. The scope of the project is purely waste at this point in time.
And why not? Because it's my question.
Yes.
Why not explosive gas bottles?
You see, it's we at the end of the day have to stick to the scope of what we've proposed, because if we try and attempt everything, what will happen is that we'll go out of scope or probably not even attain one. And also the as far as the project is concerned and the commission, it's important for us to stick within the objectives of the project, and of course the budget restraints within it.
Okay, thanks. Pity, but thanks anyway.
Another question we have here, I believe, is gonna go to Sverim, which was about how will your project streamline the scrap logistics to minimize the delays?
Yes, thanks. I think that's a tricky question. It's also kind of a key part to to the project, and also a reason why it hasn't been realized before. But now the partners in the project are, I mean, they are ready for these solutions. So so most of the small batches will be produced, but they will be stored then at the steelworks scrapyard. So the involved partners are prepared to have a large storage of container-sized batches. So roughly 10-20 tons in each container, so that 10 containers can be mixed together for one charge. Yeah, so the steelwork need to have a large storage area.
I think we have a hand raised.
Thank you very much for answering the questions. My name is Michael Rada. I'm the founder of Industry 5.0, so this is why I'm joining this event. The question to you was, Jonas, because I am not speaking about the steel work, I'm speaking about the waste industry, which creates, generally they create their business on delaying the material. So this is why I was asking, because if there is a shortage, they can sell with higher price, that's simple. This is why I ask whether it was your discussion with these parts to improve the streamline or the flow of the material itself. So, but you answered, you concentrate on the steelwork, which I do understand. I have a steelwork customer who is implementing Industry 5.0 already. So this is why I'm sure I will come back to you. Thank you for the answer.
Okay, thank you. And just to add to it, so we are working closely with Stena Recycling, and that's where we install the sensors. And so, yeah, there will be they will be involved in the logistics, of course, but yeah, to be continued how we more practically handle it in the end. Yes, so good question. Thank you.
Unfortunately, we cannot hear the moderator, so I'm not sure whether...
I'm sorry,
I was
muted. Yes, I'm sorry. We have another question, which is in regards to the data that the AI technology is planning on collecting from recyclers. Who will have access to this, and what will be available publicly, and what data controls will be in place to protect commercial competitiveness of each recycler in Europe? I'm not quite sure who the question was targeted to. Maybe it's a general panel question.
Yes, it was a general panel question. Thank you. Julianne from Enebra.
Well, I can answer this question from our side. We are going to study, right now we are studying the data management plan. We foresee to publish some of our data sets publicly, but currently we are studying to what point we need to anonymize some of the data. Then we have the intention to publish in open data repositories, but right now we are studying that. This is from our point of view in ALCHIMIA.
From the PureScrap project, we can of course not share all the details of the scrap processing and the raw sensor data, but we aim to make available the processed data and the comparison with the evaluation of at the steelworks. So we hope to be able to share enough data to evaluate.
Thank you. But will you protect recyclers' commercial, know-how, their sort of IPR? How would you protect that? Obviously, that kind of information can't be available on a public platform or any kind of public research document.
We just started our work on the IPR activities. I cannot give a good answer.
But you haven't sort of planned what and how you're going to control it to protect recyclers. Is that not something that's fundamental at the start of a project?
Nah. Well, I don't know. Yeah, I can only say that it's work that we started now to look into how.
Thank you. I'm not picking on you particularly, but it is one of the things that recyclers, I mean, obviously, ERA is the European Electronics Recycling Association, and I'm also the Secretary General of EBRO, which is the European Battery Recyclers Association. And it's one of the comments that comes up from our members all of the time, is that there's all this projects and technology ideas and, future possibilities and collection of data, but it seems at the very last minute, the protection of that data and the commercial IPR is secondary. And that's actually the primary concerns of recyclers who, quite frankly, don't feel they can get involved in new projects if their IPR and their commercial routes and the outputs are going to be protected and not available publicly. They're all private businesses. They might have shareholders, but they're private businesses. But they, they work very hard to develop their own technology, even if they buy the same machine from the same manufacturer. And I've been in the industry 24 years and can absolutely attest to this, that they will always adapt plant and technology to suit their own operations, the number of people they have, the volumes of materials that come in. So data protection and their IPR is their number one thought when looking at projects like all of yours.
May I just add a comment on this, what was just said? Don't you think that the transparency is missing instead of the secrecy? Because if the data will be transparent, we will not be in the situation when we need to start new projects, because every single one has to work on his playground, in his silo only. So I'm working for 30 years in a companies as well. But I think that the transparency is the missing part. This is why Industry 5.0 is based on transparency, profit sharing, and efficiency.
100% I disagree, sorry. I understand your viewpoint, but these are recyclers who've been in business for 50, 60 years, sometimes a lot more. One of our members is 110 years old this year, and they've developed very specific IPR technology, operations, manual, and also electronic mechanical systems, and it's also their downstream routes that is they're unique to them and who they trade with, and it's a very competitive market. These are private companies, and at the moment we're seeing a lot of all the discussions on digital product passports, battery passports, and so on, expecting recyclers to be very open and share everything, but with no incentive and no protection for their own competitive know-how. At one recent meeting I went to, the consultants talking about a digital product passport said, oh, well, the recyclers will get better known, so they'll get more business and they'll make more profit. And I'm sorry, but that is just, an amazing statement to have made in an open conference without any evidence and without talking to any recyclers who, quite frankly, were offended by that comment.
I do work with recyclers. I do work with waste industries for 11 years before I spent 30 years in logistics. Industry 5.0 is based on systematic waste prevention, which means there will be no waste. And if there will be no waste, nothing needs to be recycled. I can tell you that I do understand your standpoint, but I do not agree with it, of course, because otherwise I will concentrate on waste management, which is the third most profitable industry in the world.
And recyclers are not waste managers?
They are waste managers.
Exactly.
This is why I say that this is waste management industry, the third most profitable industry in the world.
Absolutely, from private companies.
Yes, correct.
That don't want to have their data
even the
shared.
private companies, on my opinion, even the private companies do not have the right to turn our globe into a global landfill. That's my opinion, and this is why Industry 5.0 was stated. I do not want to disturb this discussion because it was quite interesting, but thank you for your answer.
Thank you.
We cannot hear the organizer.
I think Costanzo was also raising his hand before. I'm not sure if it's still.
I think that my comment was overcome by the discussion, the last two interventions of the discussion, because the situation has to be was enlarged to the general theme of waste. Looking to the scrap only, and in particular for the steel industry, the terms of competition that we see today, or scrap company can see today, is going to be reconsidered in the time horizon of 2-3 years, 4 years, if whether the forecast of the scrap consumption is the one expected, because the disruption we are going to have relevant to the diffusion of the electric arc furnace on the one side, and also the other technologies to enlarge the life of old equipment is something that have to change the terms of competition for scrap industries. And the point is that artificial delaying that is possible today, and there are a normal tool of competition among companies, not only for scrap, for waste, can change in the range of 3 to 7 years. So it is the question. The larger question is maybe very interesting, but looking to the steel industry and the steel forecast for scrap things maybe are not stable or considered stable.
So perhaps a question that was asked before, which we could like to ask all the speakers representing all the different projects organization. What makes your initiative an Industry 5.0 feature? I don't know who would like to start.
Sorry, I don't remember the intervention you are mentioning, sorry.
It was asking, yeah, it was asking the chat why they consider their project as an Industry 5.0 project.
Oh, it is referred in general or to
Yes.
in general?
Yeah. So I think it's a nice question to ask to all the participants, well, to all the speakers of today's webinar.
I think that the question is similar to the fact that whether Industry 4.0 was a revolution or not. Everything is evolving. It is a revolution or an evolution. This question makes sense.
It is called revolution, so there are 4 industrial revolutions. But you are right, because Industry 5.0 is the first industrial evolution, because it does not concentrate on profit and money and more, but it concerns on the balance between the human and nature resource or created environment. It's generally recreate the missing link. And this is why I ask, because you know the event is named Industry 5.0. This is why I asked. If it will be called Industry 4.0, I will not know about it. So this is why I'm asking how they see themselves in the picture. And I think all of you who presented have this part of the picture, but I'm not sure if you know what is Industry 5.0 in fact. So this is slightly missing from the discussion. But as I said, I do not want to disturb this because you presented interesting projects, but I don't think at the moment they are related to Industry 5.0. But if you are different opinion, please tell me, because I would like to learn more. Just to say, Industry 5.0 was introduced on December 1st, 2015. So it's 9 years ago.
Your question is very complex. I think we'll ask for a certain time to discuss, not to respond, because probably the sentence in which you say that the Industry 5.0 is a revolution, was a revolution, and it still is a revolution. Regarding the dates, I should say that the Industry 4.0 that was the one that originated the name of revolution after the Industrial Revolution of the 16th century, of the 17th century.
Yes, correct.
Was in 2011. The definition of the Industry 5.0 became published and common in the use of the EU once in relationship with the directives.
No.
That the discussion is different. If you think about the mindset, and my question is, are you thinking to the mindset of the Industry 5.2? Or in practice?
In practice, because I am a practitioner. I started as a steel factory worker 30 years ago, so I am a practitioner. But what I would like to say, if you look at the original documents which European Commission introduced on January 7th, 2021, where Industry 5.0 was included in the European Sustainable Development Framework.
Yes, of course.
Look at the reference number 68. Because there is written Industry 5.0 definition by Mike Rada, that's me, published on February 3rd, 2017.
Yes, but
it was
you
not
have
introduced by European Commission. It's not simple true. They are breaking the intellectual property of the term. So
it's not question of the intellectual property of the term. It's a question of practice reference to this definition. The point in general stands on the fact that the discussion started probably together the appearance of the Industry 4.0. However, as everything in Europe, it becomes mandatory once a directive of the EU is published. In general, reference document can appear before, but the point of the regarding the point the I50 in a certain sense is also related to the degree of the advancement of the digital technologies that makes possible to put human in the loop, really, and not in words. I work in the digitalization industry since 30 years, and I was involved also in the appearance of the I4, the Industry 4.0 industry in 2007. The problem is that what do you mean? Now we have to give a definition of the I50, and saying that if you mean something that put man in the center.
May I ask you, what does it mean to put man in the center?
Put man in the center means to consider man as one of the most important variable of the system design. And in terms of system, I mean assets, systems or software, and whatever you want in order to defend, protect men, make men more effective and supported. And this is in few words, because we have to define something sooner or later.
The definition, as I said, of Industry 5.0 was on February 3rd, 2017. There is quite a lot of, but the latest one, it's that Industry 5.0 restores the broken connection between nature and human-made ecosystem. Why I ask you the question, where is the man in the system which you are speaking about? What you describe is that the human will become component. And I see it in factories. You know, I spent all my life in factories. And humans do things which robots are still not able to do. But a robot will never shake a hand with a man, which is on almost every single fake picture about Industry 5.0. Why should it? Humans should remain human and have a very rich function, not to be component. You know, I'm speaking to you from a place which is 75 kilometers away from a location where the term robot was introduced. It was in 1921, and the author name is Karel Čapek. And I will share right now in a chat a screenplay in which it was played. It was recorded by BBC, generally make a 100th anniversary of the term robot. And I do really recommend everyone, because if you say that human place is not a component, but it's a creative part, it's the curiosity, it's something which drives us forward, I will fully agree. But what you describe is what I see in factories. Humans do just service to the robot. The new Apple Glass, it's not for the user, it's to collect data for the artificial intelligence.
Sorry, Michael, I am an engineer. I am men live growth in factories, and for me, your mention is very interesting, but it is something that is much more complex. In any case, as an engineer and as a designer and a systemist of a control system and digital system, I could say that man is never considered, at least in my company, but also in the others, I'm sure, a component. Is a part of the chain, but the creative one, since the moment in which you design systems. Otherwise, we should say that our objective is the dark factory that is absolutely not credible up to now. And what is the main fear you find in the AI Act is exactly the contrast to this sentence. And for the moment, I'm sorry. I have to provide systems for supporting men, not for making a man at service on the systems. That is exactly the contrary. Sorry, but
I am happy to hear that. You know, I'm happy to hear that, because dark warehouses already exist for 5 years.
Yes.
First dark factories already show up. And I'm not engineer. I'm a steel worker. Originally, I'm worker. I do not have university degree. But I was able to create an industry which was named 2 years ago the leading industrial trend of a century. But not with AI. I did it with my head, with my hands. I'm loading every single day. I'm somewhere in a factory. But I am very happy that you said what you said, that the role of the engineer is not to see the man as a component. No. Unfortunately, in the factories, you know, I am disappointed because I see a very, very different picture. But I hope that we can work together and we will build it, as you said. I will be very happy. And this is why I asked the question, where do the speakers see themselves in the Industry 5.0 environment. I think it's very, very important to understand this. And thanks for the discussion. But as I said at the beginning, I really do not want to disturb this. It was a great talk to you too. Thanks a lot.
Thank you to you, because the point was very interesting. But we can eventually keep in contact.
I am on LinkedIn.
Discussion. Very happy.
I will be really happy with all of you. I put on my profile the best to connect with me is on LinkedIn generally. So I will put again the profile in the chat. Please feel free to connect. I have ambassadors in 118 countries. So and all I'm leading from here. So I will be really happy with every single one of you to build wasteless world. This is the aim of Industry 5.0, is to build wasteless world for all. So here is the connection. I cannot send to you connection. I am out of the connections for this week already. So sorry, but thank you.
No problem. We have time.
Back to the organizer.
Thank you so much. I think we need to wrap it up right now because we're already past 12 and it was initially supposed to finish around this time. But yeah, maybe those who want to put on their cameras just to see each other's faces before we close, we can do this. It would be nice. And yes, we will carry on with more webinars in the future. I think it was a very constructive first conversation, first dialogue, and first attempt at synergy building. I hope you had a pleasant experience, and we're very happy to carry on with future work on similar and also more transversal topics, which we can try to find synergies in the next stage. So once again, thank you very much. Don't hesitate to share any comments or posts as well on social media, and to follow, of course, all the projects as mentioned, because we update our pages very meticulously. I hope that you have some interesting feedback regarding this. At least on the ALCHIMIA side, we also post monthly blogs about our work. So very happy if you can check the website as well with our research. And of course, once again, thank you very much for your attention, for your participation, and very hoping that you can join us in the future and spread the word. So thanks again.
Thank you very much.
Thank you very
Thank you
much.
to everybody.
Bye.
Thank you, Anna.
Bye.
Thank
Thank
you.
you. Bye.
Have a nice
Bye.
time.
Thank you.
Love you.
Bye.